Good morning, Miss Endang and friends. My name is Dana Vincent Lau. Today I'm going to present my research report entitled The Study of Fractionation and Characterization of Extracellular Alpha Amylase from Paenibacillus pinisoli, supervised by Professor Dr. Andes Bambang Purwono, MSc PhD, and Fitri Setioningrum, STP MSc. Introductions. Starch plays a significant role in the industrial sector since both the applications and the derivatives were wide. For example, starch itself can be used as a food thickening agent in the food industry. On the other hand, the derivatives can be used as a capsule diluent in the pharmaceutical industry. In hydolysing starch, enzyme, especially amylotic enzyme, provide a higher yield and milder conditions than using the acids to hydrolysing starch. Among the amylolytic enzyme, alpha amylase contribute about 25% of the enzyme market. Considering the economical value, the stability, and the rate of growth, enzymes from microorganisms were way more demanding than the other sources, such as from plant or from animal. One of the microorganisms that have these properties was Paenibacillus species. It has been reported that these bacteria have amylotic properties to break down polysaccharides, including amylase. And from the research reports, both Naidu and Xu have 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 purified the alpha amylase from Paenibacillus species straight to the column without the precipitation procedure. And as far as concerned, there are no literature that reports about amylase production by Paenibacillus pinisoli. So enzyme purification and characterizations. So our first research objective is we want to obtain the highest alpha amylase specific activity from enzyme fractionation. And we want to study the characterization of alpha amylase, including the pH optimization, temperature optimization, metal ion and aditya effect, molecular weight, and the kinetic parameters. Hypothesis 1. Protein fractionation could be conducted by adding ammonium sulfate salt in a certain concentrations. Protein solubility would increase as the salt concentration increases, which is called salting in, and decrease when the salt concentration is extremely high, salting out. Adding sufficient salt could precipitate the protein selectively based on its solubility, according to Nelson and Cox in 2004. So if the fractionation of alpha amylase was done by different salt concentration respectively, the highest specific activity would be obtained. The second hypothesis is that alpha amylase isolated from Paenibacillus species D9 has optimal temperature and pH at 30 degrees Celsius with a pH of 6. It also has a molecular weight of 54 kilodalton. On the other hand, alpha amylase isolated from Paenibacillus acinolaticus has optimal temperature and pH at 55 degrees Celsius with a pH of 7. It also has the molecular weight of 58 kilodalton. So it was aligned with what Luang and friends said that different strains have different optimal growth environments and enzymatic production profile. So if different sources of enzyme and strains produce different enzyme profile, then each isolated enzyme needs to be characterized. Methods. First, we did the morphological and molecular identifications. First, we do the gram staining to know whether this bacteria is a gram positive or gram negative. Next, we do the DNA extraction. We extract the DNA from the cultured media. After the extraction, we do the DNA amplification to amplify the DNA using PCR box. And then the amplified DNA was purified using gel extraction, and we sequence the DNA using Sanger method. And then both the DNA extract and the amplified DNA were subjected to the gel electrophoresis using agarose gel to know how much base pairs of the DNA extraction, the whole genome, and the amplified DNA. And for the clear zone identifications, we identified the clear zone by inoculating from glycerol stock, the isolate from glycerol stock, to the nutrient agar enriched with 1% starch. And then we incubate it for 2 days at 30 degrees Celsius, and then we add some iodine solution to see the clear zone. and we can observe the clear result. For the crude enzyme production and fractionations, first we pre-culture the media from the glycerol stock to the 5 ml of NB media, nutrient broth media. And then we incubate it in the certain conditions. And then we do 2 times culture with 1% starch as a sole carbon source until the volume of the media was more than 300 milliliter of nutrient broth. And then we extract the crude enzyme by centrifugation at 12 rpm for 15 minutes at 4 degrees Celsius. And then we can collect the supernatant. And this supernatant, which is the crude enzyme, was subjected to the alpha amylase activity determination, enzyme fractionation, protein content assay, and SDS. And from the crude enzyme fractionations, first we add the crude enzyme in. So the crude enzyme was added slowly with ammonium sulfate. So we have three different concentrations, fraction 40, 60, and 80%. And then we slowly stir at low temperature for a day. And then we centrifugation at 12 rpm for 15 minutes. And then the pellet was collected and we wash the pellet with phosphate buffer. And then this was subjected to the dialysis and ST. And for the dialysis, we use the cellulose membrane. So we inject the concentrated solution, the fraction, into the cellulose membrane, and using the diacylate, which is the phosphate buffer. So we change the dialysis. So we change the diacylate every 3 hours until the dialysis running at for a day. And then the dialysis was subjected to the alpha amylase activity assay, SDS space, and protein content assay. And from the alpha amylase activity assay, we're using the Nelson and Somogyi method by adding 100 microliter enzyme into 900 microliter substrate. The concentration substrate was 5%. And then we incubate it for an hour at 60 degrees Celsius. After that, the enzyme substrate was added 1 milliliter of region of mixture A and B, the Nelson-Somogyi region, and then we incubate it for 20 minutes in the boiling water and cool it down until ambient temperature. And then we add 1 milliliter of reagent C, and then we do the dilution until 25 milliliter, and we can observe the absorbations at 500 nanometer. From the protein concentration assay, we use the benzene-coninic acid assay by adding 2 milliliter working reagents into the 100 microliter of enzyme. And then we homogenize and we incubate it for 30 minutes at 60 degrees Celsius. And then we cool it down at the ambient temperature, and we observe the absorbance at 562 nanometers. And for the alpha amylase characterizations, first we do the temperature and pH optimization. The procedure was the same as the previous, but we varied the temperature from 30 degrees Celsius to 90 degrees Celsius. And for the pH, we varied from 4 to 10. And for the effect of metal ions and EDTA on anti-activity is also the same as the previous, but we're using the optimal temperature and pH, and we're adding some salt. We're adding some metal salt containing the list of the metal ions were sodium chloride, calcium chloride, magnesium chloride, cobalt chloride, zinc chloride, and aluminum chloride, and also the EDTA. And then for the enzyme kinetic assay, it's also the same as the previous, but using the optimal temperature and pH, but we varied the substrate, the starch concentrations from 0.5 to 4.5%. Then we can determine the Michaelis constant and the Vmax. And for the enzyme molecular weight determinations, we add 10 microliter enzyme and 10 microliter of Lamley buffer. We mix that we mix both the enzyme and the Lamb buffer, and we heat it at 95 degrees Celsius for 10 minutes. And then the sample was injected into the STH batch well, and we applied electrical current 90 volt until the dye was at the below of the gel, and then we stayed with comestible brilliant blue for 1 hour, and then we destain the gel to observe the batch. And from the results, first is the bacterial morphology. You can see here that the bacteria was gram-positive bacteria, and the shape is rod shape. And for the molecular identifications, the bacterial genome of the Paenibacillus pinisoli was more than 10,000 base pairs. And for the PCR product of the 16S rRNA specific sequence, approximately about 1,500 base pairs. And for the sequence result, these microorganisms belongs to Paenibacillus pinisoli with a similarity rate about 98.61%. And from the crude alpha amylase fractionations, we can see that the crude enzyme has the highest total activity and total protein, but relatively low in specific activity. And from the fractions, the three fractions, for the fraction among these fractions, they relatively low in total activity and total protein, but it was way more higher in terms of the specific activity rather than the crude enzyme, especially the fraction 40. The fraction 40 has the lowest total protein, so yes, it also has the highest specific activity with the purification fold of 7.165. So the fraction 40 was used for alpha amylase characterizations. In terms of the pH and temperature, from the pH, the highest alpha amylase activity was at 5, pH 5, the pH of 5, and from the temperature, the highest alpha amylase activity was at 50 degrees Celsius. And from the ADTA and metal ion effect on alpha amylase, both the sodium and calcium ion increase the relative activity, while the others, like potassium ion, cobalt ion, aluminum ion, and ADTA, decrease the relative activity. And from the hydrolysis product properties, the sample dot was quite distinct at G2 and G3, which is the maltose and maltotriose. So this can be approval that the starch has been hydrolyzed into maltose and maltotriose, and the rest is the oligosaccharide or the dextrin. And for the Km and Vmax value, after we varied the concentrations, the substrate concentrations, we can determine that the Michaelis constant was at 2.22 milligram per milliliter, and the Vmax was 2.42 micromole per minute. From the molecular weight determination of alpha amylase, since the highest specific activity was the fraction 40, so the fraction 40 has 4 bands. The highest one was at 68.4 kilodalton, and the lowest was 38.5 kilodalton. And from another alpha amylase from Paenibacillus, the Paenibacillus species D9 has the molecular weight of 54 kilodalton and 58 kilodalton. So the conclusions are the specific activity of the fractionated enzyme was higher than the crude, with a 7.65 purification fold. The fraction 40 possessed the highest specific activity of 34.89 U per milligram. And for the pH and temperature optima were pH 5 and 50 degrees Celsius. Both the calcium ion and the sodium ions increase the alpha amylase activity, while the rest decrease the enzyme activity. The Michaelis constant and Vmax have been calculated were 2.22 mg per milliliter and 2.42 micromole per minute. The molecular weight of this amylase was 68.4 kilodalton and the rest is 51.8, 45.4 and 38.5 kilodalton. Thank you for your time and attention today.